Good morning for me because it's 11 a.m. here. So I have been asleep the whole night watching all the talks. Super interesting talks here. And this is my first keynote, so I hope you enjoy it. Today I'm going to try to show you and explain you my approach for hacking and learning behind the scenes. So, well, the introduction, Ellen just cared about it, but the important fact here is that I think everyone was asking about this. Is my cat is called Odin, and he's also a bug hunter. So you can answer that question because you have been asking the whole morning. So let me spoil you something about this talk before going further, and it's that you won't find answers here because we are going to be talking about questions. And let me explain you this with something that happened to me a few months ago. At the end of May, I released an advisory with a bug affecting a well-known application for gamers. And this bug got a lot of attraction. It got published on different portal news. So I started receiving different emails. But the interesting thing I noticed is that I got a lot of questions. And those questions were something like this. If you look at them, you will see that are basically questions asking about the mindset, how to start learning bugs like this, how to what do you need to know in order to find these kind of bugs, the path to follow in the learning process. So when I thought about them, I realized that I had thought about those questions before. Probably when I was reversing, when I was testing an application, or when I was reading a write-up from another researcher. So I wasn't alone. So maybe those questions are more important than we think. And that's when I realized that sometimes those questions we ask ourselves while we are hacking or we are learning could be more important than the technical knowledge that we already know. For that particular case, I released the advisory with around 7 pages, and people was not asking, or most of the people wasn't asking about the technical part, but about the learning process and the mindset behind the hack. So let me propose you something. Let me show you how I like to use questions to open up different possibilities of learning things. So I will use those questions to point out what I know and what I don't know. And that's when I start following those hints or those breadcrumbs that the answers are providing to me in order to discover different paths. And that's where basically the learning curve appears. And when we talk about learning, there are a few things that I would like to discuss and that we need to be sincere about. First of all, learning is hard. It takes time, effort, and of course, it's endless because every time we start a new project, a new gig, we start reading a new write-up, we are constantly learning. And we are constantly going through that learning curve where we don't know nothing about the application of the technical knowledge that we are reading, but we are trying to go through that curve and spend time and effort trying to master that knowledge. So my personal approach in order to identify that learning path and walk through it, through this learning curve, is to first of all split the whole problem into pieces, right? Those pieces or components could be one technical knowledge I need to master, a technique, could be something more smaller like a feature from one application, could be one feature that belongs to a framework that the application is using. So what I like to do is to focus on one of those components and then start asking questions myself. Things like how it's built, which language is being used, how it communicates with the other components, how it works internally, and so on and so on. By asking those questions, they will end up helping me to discover, for example, new components in the application and continue with the cycle. So I can focus on a different component and keep asking myself things about that particular piece. At some point, those questions may help me to identify all the components, and with some lag, and if we have been asking the right questions and we follow correctly the path, we could find sometimes an attack vector that will help us to create this attack that maybe we are looking for. So What I'm trying to explain you here is that by constantly asking things to myself about the different things that are part of the problem, those answers will help me to identify a path and to follow those breadcrumbs into the learning process, and that way traverse through this learning curve. So now what I'm going to show you are this thinking process, but with two examples, so with some bugs I found previously, so I can help you to understand better what I mean. The first bug is the one I mentioned before on the advisory. It's a one-click remote execution in Overwatch application. And Overwatch is an application that gamers use to integrate third-party plugins with their games. So let's jump to a quick proof of concept where you can see that we have a browser. And then if the user accepts this pop-up, the application is going to be launched. A cross-site scripting attack is going to be performed in the backend, and by bypassing some restrictions, some local restrictions, it's possible to achieve the remote code execution. So that's like the whole perspective, the whole overview, and that's the only thing we need to know so far. So here we have the whole graphic of the whole problem, right? The whole attack vector. We have the different components and how they communicate between them. But the interesting thing is that when we start analyzing the application, we really don't know anything about this application. We don't know how those components communicate, and we don't even know that those components exist. So let's start from the obvious, the main Overwolf process that we can see, for example, the UI. And let's start asking questions ourselves while we are analyzing this application. We can ask ourselves things like which language is being used, how it's built, it's using any particular framework, how this content is being rendered to the user, is everything static or there are other things that are dynamic. By answer those questions, we will realize that this Overwolf binary is built using Chromium Embed Framework or CEF, that this application is built using C# and C++, but the content is going to be rendered in an embed browser inside of the application that will manage all the HTML and JavaScript code that the user is seeing. So when we ask, is this content all static or we have something dynamic, and how we retrieve that dynamic content, a new component will appear. So this question has helped us to identify something else into this diagram. So we can ask ourselves things like how it communicates with the server, which protocol it uses, is this protocol secure enough? Can we probably see the traffic, proxy it in somehow in order to analyze it and see what is being sent back to the user? And while trying to answer those questions, we will realize that this communication is made using HTTPS, which seems to be secure by now, but that we could ask something different. Maybe can this application invoked remotely? And we will realize that there is another component that will help us to interact with this application from another perspective. For example, using a custom URL handler. So we need to start again to learn about this topic because we have identified something new, custom URL handlers in Windows, and we need to start learning and asking ourselves things like how this handler works, how this communicates with the application. Can we arbitrarily invoke this, for example, from any browser? And the thing is that the more we learn about this component, we will discover that this custom URL handler can help us to invoke the Overwolf application and that it can be accessed, for example, from browsers like Chromium and Firefox. So what happens when we execute this handler? For example, when a website redirects us to this custom URL, well, the Overwolf application is going to be launched. And if it's already running, the URL is going to be parsed and some different components are going to be invoked, some different features. So can we, for example, manipulate how the application behaves based it on the URL? Can we somehow use it to produce something unexpected? And the the thing is that while we ask our questions, we will realize that we can trigger some unexpected events. For example, every time we invoke this handler, a request is going to be sent to to the server, and some different content is going to be retrieved, something dynamic that comes from the server. So we can ask ourselves how this traffic is being sent. Can we see the responses? Can we somehow use this URL handler in order to trigger an unexpected result? And if we keep asking ourselves and analyzing the application and what happens every time we invoke this, we will realize that we could achieve a cross-site scripting attack inside of the embed browser of the CEF application. So we suddenly need to learn about cross-site scripting, web attacks. We need to understand and see how dangerous this attack is on a desktop application, for example, if there is any limitation, or if we can basically escalate this somehow to achieve a bug with higher impact. So by answering those questions, a new interesting component is going to appear, and it's the CEF sandbox. So in this case, we start reading and learning about the sandbox. We start asking ourselves how it works. Can we escape from the sandbox somehow? There are bugs or vulnerabilities that we already know that could help us, or that they already exist, that could help us to escape from the sandbox. And by keeping asking ourselves and learning, we will see that the sandbox is there to somehow prevent this kind of attacks, to avoid custom cross-site scripting attacks or custom JavaScript code from manipulating directly the operating system, and that it's somehow protecting the user. So we can ask ourselves, is there anything that this sandbox allow us to interact with, or can we interact with other different components? And the thing is that, yes, there is something new that appeared here, another component which is called the native API. And when we ask ourselves how this native API is built, how it works, if it has custom features, and we keep asking different things, we will realize that this native API is built with C# and C++ code again, but also is going to have some piece of code in JavaScript in the browser. So in that way, it's going to provide additional capabilities to the browser in order to communicate somehow and perform some actions with the operating system. So can we somehow use those features in our advantage, or can we invoke them from the cross-site scripting attack? And the thing is that, yes, there are some interesting features. And while we analyze this C# code, we will realize that, for example, it allows us to create new files. So those files can be anything, could have any extension, or we are limited somehow with the content we can place in that file and the names and the extensions we can create. In this case, lucky for us, we have no limitations at all, so we can create any file in the system as long as the process has privilege to write, right? So can we trigger the execution of this file? Not yet, because we are just writing the file and we don't know how to execute it. But by further analyzing this component, we can identify that there is another feature that helps us to execute any file on the system. Kind of funny, but for example, this function, if we provide an URL, it's going to open a browser. If we provide a batch script, it's going to execute this batch script. So now maybe we can ask ourselves if we can combine those two things in order to write this file, write a batch file with custom commands, and then use this second feature to execute it. And the thing is that that works, and that will help us to successfully achieve the remote code execution on this application. So let's summarize what happened here. So by asking questions, we were able to identify new components and also new pieces of knowledge that we need to learn and understand in order to go and finally identify this attack vector. We were following some hints. We were following the breadcrumbs that those answers were providing us in order to travel across this learning curve and achieve this attack vector. So let me try this again with a different bug. So we have another example. This is another remote code execution on Overwatch again, but in this case, is going to be targeting the updater process. Here we have the proof of concept, where we are going to see that in this case, what we are going to be is performing a people in the middle attack, and we are going to be stepping between the client and the server. And by doing that, we are going to make believe the client that we are actually the server, and we are going to be replacing the binaries with the installer for the new version. After that, by passing some local restrictions, again, we are going to be able to execute command as the user system and create a new file on the C disk. And this user is the highest available user on Windows. So it provides a lot of power to the attacker, right? Let's do again this graph. But if you see, this time it's not empty, because we have gone once through the learning curve before with the previous bug, and we already know things like there is a CEF application, there is a server, and we know a few things about this application. So let's start asking questions. For example, we can ask, is there any other process that Overwolf is using, or how this application gets updated when it needs to be updated? And we will realize that there is another process running on a higher privilege with the user system that is taking care of this updating process. So again, which language is built, how this process is being triggered, how it's being run and launched, and we will see that there are two different components that are possible to invoke and start this updating binary. And one of them is something called Windows Service Controller. So we start learning about some Windows internals, and we start learning how these services or this high user process can be invoked. But also we have the previous Overwolf application that we have seen before that executes this process automatically every time that it gets launched. So maybe we should follow that path because we don't need to do anything. If the application is executed, the Overwolf, the client, the process with the updater higher privilege is going to be executed as well. So how this logic works, how this updater process works, we start learning about this logic, this process, and we will see that there is a bunch of C# code with with the logic, and that this logic is retrieving the new versions and performing the installation. So how it does communicate with the server in order to retrieve those versions? Well, we again have this communication, and we start asking and questioning this component, and we say, okay, how it communicates with protocol, it's secure, can we intercept this traffic somehow? For this case, it's not that secure as the previous one, because we will see that they are using HTTP without a secure channel. So somehow we could maybe intercept or manipulate it, right? Maybe if we are in the right position. So can we manipulate it? How can we perform a people in the middle attack? Those questions will help us to start thinking about different attacks, about learning different people in the middle techniques, and see how we could manipulate that traffic somehow and probably produce an unexpected result. And the thing is that once we have learned and mastered those kind of attacks, we will see that if an attacker steps between the client and the server, for example, in the LAN, in the local network, they will be able to confuse the client in order to make it believe that they are actually the Overwolf server. So now we need to understand also what's being transmitted, right? What happened if we replace this content? And by analyzing this traffic, by proxying the application, and by understanding what's happening, we will see that there are a few things are coming back from the server. First, the numbers of the newer versions, but also the URL with the installer to download the installer, and also the MD5 checksums that those installers must match. So what happens if we replace those files? Can we, for example, force the Overwolf client with higher privilege to execute those files? By trying and failing and analyzing this, we will see that there are two local controls that will prevent us to successfully execute this attack. First, we have the checksum control, that it will validate that the file that we are going to be installed matches with the MD5 checksum that the server is returning. And second, we have a certificate signature validation that is going to validate that that particular binary that we want to execute, is going to be signed by Overwolf. So let's start asking about the first check. How does it work? How is it implemented? Which functions are using from C# in order to control it? Is there anything we can use to create, for example, a collision or to bypass this checksum? And the thing is that if you pay attention to the previous answers, you may have noticed that the checksum was also coming via an insecure channel. So in that way, we could replace not only the URL with the installer pointing to our malicious file, but also we could replace the MD5 value, and in that way force the application to believe that that binary hasn't been manipulated. So the first check has been bypassed. Now, is this enough to achieve remote code execution? Not yet, because we still haven't bypassed the second control, the certificate signature. So now we need to start learning again about this component and start thinking about how we could bypass this, how it's implemented, which is the certificate authority that is being validated, or maybe if we could use a self-signed certificate and see what happens, right? An interesting thing is that the longer we keep asking and learning about this component, we will see that due to some C# internals, the developers weren't using the correct function in order to validate the certificate. So maybe we could use a self-signed certificate to bypass this control. And luckily for us, the answer is yes. By signing the binary with the self-signed certificate, it's also possible to bypass the second control and finally achieve the remote code execution. So again, in a nutshell, we have the questions, we have the knowledge, and we can see how by learning and asking about the language, how it works, how they interact, how it's expected to behave, and how we can manipulate that expected behavior, we're going to identify the different pieces of knowledge that we need to start learning and reading and mastering in order to, for example, look for similar bugs like this. Or now that you see the mindset and I have shared this with you, let's jump into some conclusions. First, what do those bugs have in common? And the interesting thing is that I wasn't looking for any of those bugs while I was reversing that application. I just started like the same we did here. I start analyzing one component, focusing on one component, and start asking things to see where I could go. I start following those breadcrumbs, those hints that the answers were providing me in order to follow that path and identify that attack vector that I wasn't looking for. I couldn't end up finding a previous escalation bug, but that will depend of the questions and of course of the answers. What do these questions tell us? Well, basically is that sometimes the things that we don't know could be more important than the things that we do know, because those questions help us to identify the things we need to learn, the things we need to discover, those voids that we have that we need to find out and understand in order to discover new things and probably attacks or vectors. And of course, the right questions come with practice. The more we ask ourselves things about different components, the better are going to be the questions, right? With the practice, we will know how to question different components in order to find those paths. And during this talk, I provide you the answers immediately because I already traveled that path. But sometimes when we are working on researching, those answers can take minutes, days, maybe weeks. So don't get disappointed if you are trying to find out some answers, but it's taking too much time to do it. Finally, is that if we ask questions that don't help us during the research or the learning process, that's fine, because that answer that didn't help us, it means that we learned something, or maybe that path that we were trying to go through is not the correct one, and that we need to find our way into the breadcrumbs in a different way. And what I want to show you here is that this can be applied everywhere. I like to go through this mindset process, to this mental process for everything. For example, when I'm hacking a new application, a web application, desktop, whatever I'm doing, for example, when I'm learning a new technique, or simple when I'm reading a write-up. I like to start asking questions that the write-up is not mentioning. So I start focusing if, for example, a write-up mentions a technology, a framework, or something. I start asking things about that and start trying to find those answers by myself. Because in that way, I can take any write-up, start asking things to the different components, and probably start understanding a lot of more information, or probably learning that new attack that I'm learning and that I'm reading and I didn't know about it. So that was all for the talk. I hope you have enjoyed. So now, do you have questions for me?